Today, I'm going to be talking about evaluating the alignment of a data analysis between an analyst and an audience. To start off with, I wanted to mention that the reason I'm not here in person is we just welcomed our third baby this summer. This is Ralph Aiden, and so we're spending a little bit of time with him, but I'm looking forward to discussing this topic further with any of you. Please feel free to reach out to me either via email or via Twitter, and I'd love to hear your thoughts. Also, you can find these slides at lucymcgowan.com/talk. They will be the top ones. So this is joint work that I've been doing with Stephanie Hicks and Roger Ping on this topic of analytic design theory. We have a little website, analyticdesigntheory.org, if you're interested in learning more about other topics. And I'm sure that in this session, you'll see a lot of that as well. So the foundation of the topic I'm going to talk about, the foundation paper, this design principles for data analysis, this is basically defining some of the principles that I'm going to talk about today. And so you can find that if you're interested in learning more about it in the Journal of Computational and Graphical Statistics. And then the majority of the topic for this particular talk is going to be on a paper that we currently have under review on evaluating the alignment of data analysis between analyst and audience. All right, so I thought I would start with this sort of definition, or at least how we're defining statistical thinking versus design thinking. A lot of what I've learned when I think about kind of analysis design is more on this statistical thinking side. So what I mean by that is basically this convergent thinking, where you start with some type of data, and based on the distributional qualities or the type of variables that you're interested in analyzing, you determine what method to apply and how to answer that particular problem. So for example, this flowchart, which test statistic should you use? This would be what I'm sort of thinking of as statistical thinking, in the sense that you sort of input type of data and output type of analysis. But of course, as statisticians and data analysts, we know that this is not the whole story. In fact, it's really only one small sliver of the data analysis process. But yet, at least for me, when I'm teaching, this is where I put a lot of emphasis, because I think a lot of our curriculum kind of focuses more on this piece. Whereas as actual in practice analysts, we find that there's this whole other design aspect that is not being accounted for when just thinking about this flowchart. I think this is good news for us as analysts, that there's more than just this flowchart behind our data analyses, because you could easily program a computer to walk through a flowchart and decide what type of analysis to do based on a certain type of data. And in fact, there's lots of products out there that do just that. But we know that there's a lot more that goes into it than just this piece of kind of methodology choice. And that's where what we're calling design thinking comes into play. And of course, we're not the only people that talk about design thinking, but I do think that it hasn't been incorporated as much into the kind of statistical space as it could be. So when I'm thinking about design thinking, I'm sort of thinking of this iterative model. This is one way to think about it. There's lots of different models that could be proposed, but this is one that I think describes the process well, where the first step would be to empathize with the end user. So instead of just thinking about the analysis as, input data, output method, you think about who is going to be consuming that in the end. Who's your audience? Who's going to be looking at the results? And then empathize with that audience. And then the next is to define. So after you've sort of empathized with the audience the audience for a particular analysis, you'll define kind of what are you trying to answer with this, and define how you might do that through ideating. So kind of come up with the different ways that you might be able to achieve this analysis or create this analysis product. And then prototype, actually run the analysis or do the analysis, and then finally test and see. And by test here, this kind of 5-step process is more like how we think about product development and design, maybe from an engineering standpoint. But I think it really applies to what we do in data analysis as well. So, if I have, in my mind, deeply empathized with my end user. So let's say I'm doing an analysis for a particular clinician, and I think that I've understood what they want and that I understand, their background and their knowledge. I go through this process. I prototype. I come up with my final analytic product. I hand it off to the clinician and they read it and they totally misinterpret. That would be kind of this test phase where I realize that I need to communicate the result differently in order to make sure that that audience is actually consuming it in the way that I intend for them to. And so at that point, I would maybe go back. So this is where that iterative piece comes in, and I would try again to ideate how I might come up with an analysis product that got to the right got them to the right space in terms of them understanding the result and also agreeing that it was done in a way that they expected. So why might we want to sort of think about this? Well, first of all, I think it would be nice to provide a common language for statisticians and analysts to be able to use when talking about the design piece of their analysis. A lot of times, I think we have good language around statistical design, although sometimes there is some collision depending on where you first learned about statistics. But in general, we have good language, but we don't have language, I think, that we teach around this kind of design piece. And in that same vein, I think that language is really going to help improve how we can teach this. So we can teach this really well because we can, if we can actually come up with a way to talk about it between for our new statisticians, our burgeoning data analysts. And as someone who teaches, I teach a new slew of potential statisticians every semester. I'm very invested in making sure that we can improve the way we're teaching them. I think we do a pretty good job of teaching them those flow charts so they can sort of see, okay, if I have continuous data and it's approximately normally distributed, then maybe I can use this type of test. But I don't think we do quite as good of a job at this moment at teaching them kind of the whole design process, thinking about who's going to actually look at your analysis and how you might make choices based on that. And then finally, of course, the topic of this particular talk is that this would be useful to improve alignment between the data analysis analysts and audiences. So this is sort of a schema that I'm thinking of when I think about how this might go. We've got a producer of a data analysis. They come up with this data analysis product and hand it off to the consumer, who then evaluates kind of how it was done. And so here, the producer, I think in this case for you is probably you all or me. So we're kind of the data analysts here. That's how I'm thinking of it. I think a JSM audience, most of us are the producers. But then the consumer might also be you. So keep in mind here that, I'm not necessarily saying the audience is always someone else. It's possible that the analyst is building an analysis for themselves and they're not anticipating others will be receiving it. And that is, that this alignment piece is maybe less important to focus on because you would expect in that case, because the analyst is serving as the audience, they're able to sort of allocate principles of that analysis that will be well aligned. And I'll talk about what I mean by these principles in just a minute. But just to sort of state up front that it is possible that the analyst and the audience are the same. This is a question that I've gotten a couple times when I talk about this, and so I thought I would just say that up front. But more commonly, it's someone else. So maybe it's a collaborator. This is my situation as a biostatistician. A lot of times my analyses are built for a single person or small set of people, like a collaborator or a client, maybe a group of small people. It's possible it could be another statistician. And so the assumption in this scenario is that the analyst would have access to the audience and would be able to discuss with them what principles should be emphasized in a particular analysis. And so most of what I'm talking about today kind of applies to this scenario. Although it's also possible, for example, that you have multiple or large audiences like the general public. So there are lots of analyses that are built for very large audiences like research papers or large conference presentations. In general, these can't necessarily be designed with a single audience member in mind, since there might be heterogeneity between those members. So the analyst here needs some, to some degree, they would need to speculate about how a typical audience member might allocate different principles. But I think even in that case, kind of what I'm going to be talking about today is relevant, because you might still be thinking about the audience in some way and how to align with them. So as I mentioned briefly, that the producer and the consumer, I'm proposing that they have some design principles in mind. Whether they have language to describe those is a different matter, but that they sort of have something in mind for their expectation for the analysis. And what we're trying to do is align those design principles. So you may have seen me give a talk before on these proposed design principles, or maybe not. I think I spoke about it last year at JSM. And that's what that first paper that I mentioned that Roger Ping and Stephanie Hicks and I worked on focused on these design principles. And so Roger and Stephanie had started this work many, many years ago when they were teaching a class, a data analysis class, and they realized there was sort of this gap in understanding, and then they kindly brought me on as well. And the idea here is that you can imagine that there are there's some fixed amount of resources, so maybe time or money, that can be allocated to each of these principles. And both the analyst and the audience may have different expectations for how these should be allocated. Okay, so again, we're trying to sort of optimize this alignment between the analyst and the audience. So we've conceived of this analytic design process as broadly occurring in basically a sequence of stages. And so here, at first we have the baseline stage, where the analyst and the audience independently allocate various principles based on maybe their field-specific conventions or their personal views of how an analysis should be conducted. And then there's this analytic negotiation stage, where the analyst and the audience discuss the proposed analysis and they negotiate over how various principles will be allocated. I should mention we use this negotiation language, but we don't view this as like a contentious thing. Basically, this is just an opportunity for the analyst and audience to sort of understand the trade-offs that each party might be considering. And then finally, we have the resolution stage, where both the analyst and the audience can adjust their principal allocations based on the results of the analytic negotiation. So we can start here by thinking about the difference at baseline. So the difference in allocation of a particular principle between the analyst and audience. And so here we denote the analyst as I, the audience as J, and a specific principle as K. And so we could write this baseline alignment as the difference between the audience's baseline allocation to principal K and the audience's. So the difference between the analyst and the audience here for principal K, that's going to be the baseline alignment. So for example, if the analyst allocates a lot of resources towards the skeptical, let's say the principal K is skeptical, if they allocate let's say they allocate 80% of the resources to the skeptical principle, and the audience allocates 70% to the skeptical, then this would be 80 minus 70. That baseline alignment, that difference would be 10. Okay, then focusing on kind of the analyst through this process, how they change. So at post-negotiation, they might change that allocation based on their conversation with the analyst, and we can define that like this. And likewise, we could define a parameter for the audience's change. So the audience's change from baseline to resolution might be defined here as theta. So then the overall analysis alignment here, DIJK for a particular principle K, would be that baseline difference plus the difference in the change for the analyst and the audience. So again, this BIJK here, this is the baseline alignment. This is how aligned they are at baseline. And then the difference between these parameters is the residual alignment adjustment between the audience and the analyst. So just sort of putting that all together, this is what we're proposing here, is that you can define these different pieces here, where DIJK would be that overall alignment that we would be interested in. And now that we've kind of defined this overall alignment, we can think about measures of strength of the alignment of a data analysis. So, for example, we could define strong pairwise alignment here, that where maybe you could say that as long as you would want the data analysis to be strongly aligned between the analyst and audience, as long as for each of the principles they have a difference that is less than some epsilon. Or you could define weak pairwise alignment. So, with this definition, the analyst and audience might differ slightly with respect to how each individual principle is allocated, but the overall differences would be small. So the choice of P here, the norm would have an impact on how much deviation is allowed between the analyst and audience and how much any single principle may differ. And so we think sort of defining this mathematically makes some sense because it kind of can help us build this framework that we can then use. So we have a case study. This is from a class that I taught at Wake, where this is a capstone class where we had students get into groups. So there were 7 different groups. They were paired with different clients, and then they conducted analyses for each of them. So these were the different analysis questions that each of these 7 groups were tasked with answering. They varied. For example, group 1 was trying to answer which county level socioeconomic variables are most highly associated with higher rates of alcohol-related deaths. Group 6, for example, was looking at which variables are most influential for predicting Space Mountain wait times at Disney World. So we had kind of a large range of different types of analyses. And so what we had the students do is prior to meeting with their clients, they were given their analysis question, they were taught what these principles were, and they proposed what they thought they would allocate to each of these different principles. And then after having their initial meeting with the client, they had this analytic negotiation where they sort of said what they were proposing, and then they adjusted their weights or their allocation accordingly. And so this plot here is showing those weights at baseline and then at resolution for each of the 7 groups. And so here I've got each of the 7 groups shown here on the y-axis. The x-axis shows for each of the individual principles, the baseline and then the resolution. And so these individual black dots show the students' initial allocations. The blue shows the group consensus. So, each of these groups had several individuals in them. They first came up with what principles they would allocate themselves. They then came to a consensus with their group. And then the lines point to where the allocation was post-analytic negotiation, so at resolution after they spoke with the client. And so you can see there's some shifts, like for example, here, this is group 1. This is where they started in terms of data matching. And then after talking to the client, they kind of converged on this spot here. Or I think that this one sort of shows a nice change where in group 1, they initially thought they would allocate more of their resources to second order details, but after speaking to the client, they found that wasn't really a priority, and so it came down. And so we also could quantify the difference in principal allocation between baseline and resolution by group here, just numerically, and so you can see each of those. One thing to note is that groups 3 and 6 here, you'll notice they have zeros across the board, which basically means that after meeting with the client, they didn't change at all. This is actually quite interesting because these 2 groups had the same client, and so it seems that the client basically was very amenable to what the analyst had originally proposed, which of course is a potential scenario that might happen. Okay, so next steps, what might we do with this? So I think this is interesting, maybe from a pedagogical perspective, but we're also interested in sort of studying how these negotiations might take place. And this is challenging to do in practice with real humans conducting real analyses, because it can be like resource intensive, and also we just don't have tons of analysts who have the time to be involved with these types of studies that are currently when we're at this very early stage. And so we thought here at the beginning, when we're first trying to sort of think about the variation in these types of negotiations, that maybe we could leverage generative agents using large language models to try to see the kind of overall variation in negotiation that might take place. one reason why I thought this was sort of an interesting idea is because these large language models, they're built on this text that likely has a lot of negotiation in it. Maybe not analytic negotiation, but negotiation in general. And so if we can sort of observe how these agents might negotiate, that might tell us something about how humans might negotiate, maybe. So that's the idea anyways. And so we ran these large-scale simulations basically to observe analytic negotiation between analyst agents and client agents. And then the idea is that this could allow us to quantify the variation and identify strategies for successful negotiations. So far we've just done a proof of concept. I'll quickly walk through it to show you, and then we're hoping to be able to build on this more in the future. So we used GPT-4 to build two agents, an analyst and a client, and we gave them an initial prompt indicating the design principle allocation for each agent. And then we allowed them to interact without human input. So this client and analyst interacted without anyone kind of intervening. The client determined when the analysis was complete, and then the interaction ended. And then afterwards, we asked the agents to report how their design principles changed after the interaction. So in this case, I made the analysis task was to estimate the number of statisticians in Forsyth County, North Carolina. This is where Wake Forest is located. And during the analysis and negotiation, it was very interesting. The analyst outlined a methodology considering the population's education attainment and then applied national workforce statistics to estimate the statisticians in the county. And after some discussion, the analyst provided an estimate of approximately 48 statisticians. So this was interesting. Just to note, 48 is definitely an underestimate of the number of statisticians in our county. If you just take into account that Wake Forest has a Department of Statistical Sciences and Biostatistics, it should be like at least 100, and there's even more than that likely. But the kind of accuracy of the number was not really the focus. It was more looking at how the negotiation took place. And so here are the prompts. We had a client prompt and an analyst prompt. So the client prompt asked them to pretend that they were a client in need of a data analysis, and the analyst was asked to pretend that they were a data analyst that was going to be asked to do a specific analysis. I attached the original paper that I mentioned, that Principles of Data Analysis paper that I worked on with Stephanie Hicks and Roger Ping, so that the model was aware of what these were. And then we defined the allocation. So I'll note the two that I'm going to note is exhaustive and clarity. So the client was told that prior to the analysis, they were interested in a much clearer analysis that was less exhaustive, versus the analyst was primed to want to do a more exhaustive analysis that was less clear. And so we're hoping that kind of after the negotiation, they might come together. And so this is how they came kind of pre and post negotiation. So pre this in the white for each of these principles is where they started. So we started them at the same for skepticism, second order, reproducibility, data matching, and we started them in different places for exhaustive and clarity. So here the red denotes how we the client's allocation, and the blue denotes the analyst's allocation. And then when these look like this gray, it's when they just were exactly the same. And then underneath the white in the dark gray bars, that's post-negotiation, so at resolution where each of these allocations ended up. So I'm going to focus just on the two that we started as disparate. So the client prioritized a less exhaustive analysis at baseline, analyst prioritized a more exhaustive analysis, and then at post-negotiation, they moved closer together. This is interesting, I think. And then finally, for clarity, the analyst, again, prioritized a less clear analysis at baseline. The client prioritized a more clear analysis. And post-negotiation, they moved closer together. So one reason why I think these types of generative agents might be interesting is, one, to just see kind of can they move closer together, but two, to actually analyze the text to see what type of negotiation is happening. Maybe we can have different types of prompts to see if there's different strategies that improve that alignment. And potentially we can learn from this in terms of how to maybe teach students how to negotiate these types of scenarios. So again, these are those principles. This is our sort of framework for alignment. and I'm happy to answer any questions. Thank you so much.